Video is on scaling fractions. What that means is being able to look at a multiplication of fractions problem and being able to predict if the answer will be greater than, less than, or equal to the original number being multiplied. There are three scenarios that I'm going to go through explaining how you can predict what the product's going to be. And in each scenario, my original number is going to be a 6. That way it makes it easy to compare, and we only have one variable changing, and that'll be the number we're multiplying by. So in this first scenario, I'm going to multiply my original number, 6, by a fraction less than 1. Now, to determine if a fraction has a value less than 1, you would take a look at the numerator. If the numerator is less than the denominator, then the fraction has a value less than 1. So we're not actually going to find the product or find the answer. We're just going to basically predict what value the answer will have compared to the original number. So if you multiply by a fraction less than 1, then we can determine that the product will be less than the original number, which was 6. So 6 times 1/2 will result in an answer that is less than 6. Now, we could prove this and verify it. We could actually solve it. If I multiply 6 times 1/2, I will get an answer of 3, which is less than 6. So these are predictions that can be verified or proven as well. So with the second scenario, my original number is going to be 6 again. This time I'm going to multiply by a fraction greater than 1. So a fraction greater than 1 could look a few different ways. It could first be an improper fraction. If the numerator is larger than the denominator, then we know that fraction has a value greater than 1. If it is a mixed number, which a mixed number is where you have a whole number mixed with a fraction, mixed numbers always have a value greater than 1. Or if you just have any whole number greater than 1, 2 and above. So any of those three types of numbers, improper fractions, mixed numbers, or whole numbers greater than 1, all have a value larger than 1. So if you multiply a fraction or a number greater than 1, then you can predict that the answer will be greater than the original number. So 6 times 9/8 will result in a product that is greater than 6. And again, I could actually solve the problem and prove my prediction. The last scenario is I'm going to multiply my original number of 6 times a fraction that is equal to 1. So it could just be the number 1. But since we're talking about fractions, I'm going to choose a fraction equal to 1. You know a fraction is equal to 1 if the numerator and denominator are the same. So 4 over 4, 10 over 10, whatever the case may be, that has a value equal to 1. And our identity property of multiplication tells us that anything times 1 is the original number. So any number times a fraction equal to 1, we can predict the answer will be equal to the original number. 6 times 1 is equal to 6. Now, the purpose of being able to predict your answers of will they be getting greater than, less than, or equal to is just being able to check for reasonableness when you are finding your exact answer. So, for example, if I were to multiply 6 times 1/2 and I were to make a miscalculation and get an answer of 7, I would know that that's not a reasonable product because my answer should be less than 6. So it just allows us to check for that reasonableness to see if our answer could be correct. It's just the same as when you estimate an answer before finding the exact answer. It just lets you know if your answer is going to be reasonable.